Hey guys, welcome to our channel. Today we're going to be talking about how encryption works. Now, a lot of the times, encryption is made to seem a lot more difficult than it is, but within this video we're going to be showing you how simple it really is to understand. Now, encryption is used in a lot of different places, including social media websites and communication platforms. On this slide, we show examples from FaceTime, and iMessage, and Gmail. One of the other places that you might have seen encryption being used before as well is on WhatsApp, with this text appearing on the top of your chats, explaining that end-to-end encryption is being used. We'll speak more about this later. But in the meantime, what really is encryption? Well, the dictionary definition that comes up states that data encryption is a cryptographic method that protects sensitive data, such as credit card numbers, by encoding and transforming information into unreadable ciphertext using keys. While this idea of keys and encrypting might seem very daunting at first, it's in essence simply changing a message into a special encoded message that only the sender and receiver can understand, but no one else. So now that you know in simple terms what encryption is, we need to now understand what exactly a key is and how it works. So in cryptography, a key is used in combination with the message that you want to send in order to transform the message that you have into the encoded text, and as such encrypt it. Once this has been done and the message is then received by the other party here, this needs to now be decrypted so that the receiver can understand it as well. This decryption can be done using either the same key or a different key, depending on the situation. And this is done in order to transform the encoded text back into the original message for the receiver to understand. You might see these words plaintext, ciphertext, and cipher thrown around a lot in cryptography, but these definitions are just longer, more complicated words to explain what we've been talking about up till now. The plaintext is just the message that you're trying to send, while the ciphertext is the encoded message that no one except the sender and receiver can understand. And finally, the cipher is simply the mechanism that is used to convert the plaintext into the ciphertext in encryption, or vice versa in decryption. Let's take an example to make this clearer. One of the most well-known ciphers is known as the Caesar shift, named after Julius Caesar, who would use it to encode his military messages. It works by shifting all the letters in the alphabet a few places along from where they would normally be. For example here, if we were shifting every letter by 2 to the right. This means, for example, that C would go from C to D to E, and as such, move by 2 to the right. So although the plain text would be C, the encoded ciphertext would be in E. As you can see from the diagram on the slide, this pattern is cyclical, meaning if you were trying to encode the letter Z using this cipher, the encoded text would be from Z to A to B. And again, this is +2. Let's put this into practice. Let's say that Caesar wants to send the message to his soldiers saying to attack. He wants to send it in such a way that if the message gets intercepted by an enemy, they wouldn't be able to understand what it's saying. So instead of sending this plain text message, He sends an encoded message, aka ciphertext. In our example, the way he does this is by shifting the letters in his original message forwards by 2 places in the alphabet. So for his first letter A, he'd move forwards to B, then to C, meaning his encoded letter, aka ciphertext, would be C. He could also do this using what we have here on the slide called a cipher wheel. And this is specifically for this scenario, moving the letters by 2 to the right or to the left. So here, he would move from out to in. So here, he'd go from A to C. And as you can see, this works in practice as well. It's just adding 2, but in a slightly easier, more visual way. So for T, he'd do the same thing, T inwards to V. And the same for C and for K. So the encoded message would now read CVVCEM. Clearly, this is not an understandable word, so even if the enemy was to intercept this message, they would not be able to understand what it means. Caesar's commander, however, who Caesar is actually sending this message to, this ciphertext to, has already been told how to decipher it. He has this cipher wheel as well and knows that if Caesar has shifted his letters forward by 2 places, then he has to shift them backwards again in order to decipher it. So if he was using the cipher wheel, instead of moving from out to in, he would move from in to out. So for example, he would take the first letter, C, and he would go outwards to A. And again, this holds up if you do it the longer way as well. C, back 1 place, B, back another place, A. And as you can see, this is doing the exact opposite to how cipher encoded it, thereby decrypting the message. The same thing is done for V, so that becomes a T now. Same thing for E over here, and that becomes a C. And finally, same thing for M, which becomes a K. So now the soldier as well has got the original plain text message. He has decoded it. Now moving on to a more modern example, many communication platforms use end-to-end encryption, like what we talked about being used on WhatsApp. In the previous example, the cipher wheel remained the same for Caesar and for his commander, meaning that if any enemy soldier found the cipher wheel, they would be able to decode the message. In the modern encryption, therefore, instead of having just one key or mechanism that both encrypts and decrypts, there are 2 separate ones. One is used to encrypt, and it is called the public key, meaning it's available to everyone, while the other is used to decrypt, and it's called the private key. And only the receiver has it. This is far more secure, as no one can decipher the message except the receiver who has the private key. And this method of encryption is known as asymmetrical-key algorithm. What this means is that what is encrypted with the public key cannot then be decrypted as well with the same key that everyone has access to, right? And therefore only the receiver can decrypt the ciphertext back into the plain text using their private key. While hackers and the public could see this ciphertext and they have access to the public key, the one that encodes the plain text, they cannot make sense of what is being sent, as it's completely different from the plain text. So now, just as a sort of summary, let's go through the steps that are used in asymmetrical key algorithm. So step 1, the sender encrypts a plain text message with the public key that anyone can access. So let's say we've got a sender here, and she wants to tell her friend, hi. So she's going to use her public key, right? And she is going to encrypt the message. So note that although everyone can see this public key, they can't access the original message. Only the sender can at this point. As well as this, the resulting ciphertext can be seen by the public as well, but it also cannot be understood as it's in the jumbled form and can only be decrypted with the receiver's private key. So let's say that this public key transforms the plain text into the ciphertext XA. So now let's move on to step 2. Step 2 is that the sender sends this ciphertext to the receiver, her friend. While this message is being sent, if somebody does happen to intercept it, then they wouldn't be able to understand it because it only reads XA, which is not a word that makes sense. Next, step 3, when her friend receives the ciphertext message, over here again, so they receive XA, she just now needs to decrypt it in order to understand it. So she therefore has to use her private key here, which is in green as you can see. So it's not the same as the public key. Different colors, different keys. And she therefore uses her private key in order to decrypt this ciphertext message back into the original plain text, aka the original message, hi. So that brings us to the end of this video. Thank you so much for watching, and please feel free to leave a comment down below if you have any questions or feedback. And look out for our next video explaining the maths behind creating the public and the private keys. Make sure to leave a like and subscribe if you enjoyed this video, and we'll see you next time. Thank you!